We still need to wrap up chapter 7 here, so we have 2 sections left. They're both trig algebra. Right? So we're actually solving for the thetas in these problems, or the x's, whatever. But we're looking for, when I'm looking for theta, and let's take a look at example 1, what does theta represent here when it's sine of theta?
Something opposite over hypotenuse.
It's an angle. It's an angle. Okay? So I'm not trying to find some type of length. I'm not trying to find some type of measurement of a side. I'm looking for an angle measurement. Okay. So basically, I want to do the same thing that I've been doing all along. I want to try to get things away from the theta. All right, so what are the things that are keeping theta from being by itself right now?
2 minus 1.
The 2 and the 1, and technically the sine, but we're going to let that one slide for now. All right, so what should I get rid of first here?
The 1.
Okay, how?
The 1 or
Hands.
Okay. Okay, and then what?
5 by 2.
Okay, so I get sine equals 1/2. Now, remember, now over here, I'm only interested in what's happening in between 0 and 2 pi, because sine goes on forever and ever and ever, and it just keeps repeating. Right, so I'm only interested in the values for theta that are in between 0 and 2 pi. All right, now where will sine be 1/2? What kind of triangle is that going to be?
30, 60.
It's going to be a 30, 60, 90, where the opposite is the 1 and the hypotenuse is the 2. Okay, so what kind is that going to give me?
30 degree.
It's a 30 degree, all right, in the first quadrant. All right, 1, 2, square root of 3, and that can be my theta there. So that means that one of my answers for theta is pi over 6. All right, now, sine is positive 1/2. Where else is sine positive? In the second quadrant. So we have to consider that one too. Still a 30 degree angle. This is negative, but that doesn't affect it because it's opposite over hypotenuse. So I'm good there. What angle is that going to be?
That will be 7 pi over 6.
Close.
No, it'll be 4 pi over 6.
You are also close.
5 pi over 6.
Oh my gosh.
I forget this.
Well, if I was here, that would be pi. So that'd be 6 pi over 6.
It's 5 pi over 6.
5 pi over
I
6.
said that, and then I
You
confused
said
myself,
7
and
and
I
4.
said it again.
All
I
right,
went
so
7, 4, 6, 5, something.
5 pi over 6. Are there going to be any other places where sine will be a positive 1/2?
No.
There will be a couple places where sine would be negative 1/2, but these are the only ones that are in between 0 and 2 pi, so those are my 2 solutions for that one.
Cool.
That's all we have to do.
Right. All right, let's take a look at this one. I've already got this one actually solved out for you. Okay, so cosine of theta is 1/2. I'm only interested in the stuff in between 0 and 2 pi.
That's a 60 degree, right?
Well, this is going to be adjacent over hypotenuse. So, yep, that's going to be one of them. So it's going to be here, where this is a 1, a 2, and a square root of 3. So it's adjacent over hypotenuse.
Look at this.
So what is that in radians?
Pi over 3.
Okay. Now, where else is cosine going to be positive?
4.
In the fourth quadrant. And it's still going to be that 60 degree angle, except it's going to be down this time.
It'll be 5 pi over 3, right?
Correct. Because if I went all the way around to 2 pi, that would be 6 pi over 3. 1 back is 5 pi over 3.
So did I really mess up?
You did. Let's try that one. What should I do first?
Ask him, Jack.
5 by 2. Sine theta equals
Okay, now what kind are we looking at here? This is where my opposite.
it's another 30, 60, 90.
Okay.
Uh,
Now, where is sine negative?
it's gonna be 30. It's gonna be a 60.
Third and
degree.
fourth quadrant. And the opposite has to be the square root of 3.
So it's a 60.
So it's going to be 60s down in the third quadrant and in the fourth quadrant.
But what is
where this is 1 square root of 3 and 2, and these are negative. This is 1 square root of 3 and 2, and that's negative. So that my opposite over hypotenuse is negative square root of 3 over 2, and my opposite over hypotenuse is negative square root of 3 over 2.
So that's 4 pi over 3 times 3.
Good. 4 pi over 3, because it's 1 past 3 pi over 3, and 1 back behind here, so 5 pi over 3. Good. Kind of see how these work?
These are easy.
You're going to get more than one answer in most cases.
Can you ever have more than 2?
You could have more than 2. Especially like if you have to take the square root of something, remember you're going to get the positive and the negative version of it. So let's say if I have something that comes out to be the square root of 1/4, right? I take the square root of both sides and I end up getting positive and negative 1/2. That opens up all the quadrants, because where would sine of 1/2 be positive? The top two. Where would sine of theta be negative 1/2? In the bottom two. So you're actually going to get 4 solutions for that.
So like the equations like 2 sine theta, those get harder than those.
Mhm.
Right, can we do one that's harder?
Yeah, let me see if I've got any.
Actually difficult one.
All right, these can be kind of tricky.
I don't want tricky, I want hard.
Okay, well, one more for you.
Well, if you do a hard one, you know how to do it.
All right, so what would I have to do for this one? Well, how's this one different than the ones that I've already done? How about that?
Double angle.
Okay, so it's a double angle. I haven't had one like that yet.
Would you use
How
a
do we get
double
rid of
angle
that too?
formula or?
How do we get rid of that too?
Well, I don't need to use a double angle formula,
How do we get rid of that too?
but I know that last time we did one that was actually very similar to this already, right? We did sine of theta equals 1/2. And what happened for that?
I mean, that's theta would be
You just divide the thing by.
Well, let's look at it this way. Let's let this be x. All right, so now we're looking at sine of x equals 1/2. That's not so bad.
So that's a 30-degree angle, right? And the first.
Right. Well, because it's a 1/2, so we already did that one. So this is my opposite and my hypotenuse. So the opposite is going to be 1 and the hypotenuse is 2. Okay, so we know that we're going to get a pi over 6. And then what else did we get?
5.
A 5 pi over 6.
Oh wait, 6 pi over 5, wait, 7 pi.
Okay, right? And that's when I had it sine of x, right? But it's not an x. It's 2 theta.
So is that your answer?
No, I'm looking for theta.
so you divide.
So now we divide both sides by 2. I'm sorry. Same thing as dividing by 2 is multiplying by 1/2.
Oh, that's.
So I'm going to get pi over 12 and 5 pi over 12.
Alright, that's not hard.
Okay,
It's easy.
but we're not done.
Oh, we're not.
Oh no.
What?
When we were graphing these things, what did this do to my graph when I had a number in there?
Something about something.
Something crazy.
It did do something about something. Thanks, Ryan.
Was it the amplitude or
Guys are
was
killing
it
me.
the,
Not the amplitude.
Oh, it was the.
Well, you saw me do that, man.
Okay, it was the wow.
Is it the cactus? The Pepsi sign.
Yeah. All right, it changed the frequency.
I said that.
You're right. You're right. So this, I can't do that. All right, the frequency was changed. All right. So is this one? Is it going to get squeezed this way, or is it going to get pulled out?
No, it's
Squeeze it.
It's going to squeeze it in. All right. So what that means is I'm going to have the frequency is going to happen more often. So I'm probably going to have more than 2 solutions here. All right. So what we've already got these 2, and those are going to be viable solutions. All right. But when now I have to add pi. All right. So these are 2 of my answers. I've already got these 2. But any other ones, now I have to make sure. Now, where do I stop? I'm going to keep going. I'm going to keep adding pi
Oh, you stop it.
to my solutions here because it's going to keep, because we're really trying to find every place that it crosses the x-axis, right? Because whenever we do these, we're always trying to find the zeros. The zeros are really the x-intercepts, right? And how often does the sine curve cross the x-axis? Every pi, okay? It doesn't start repeating itself until 2 pi, but it crosses the x-axis every pi. So what we want to do here is we're going to start here, and we're going to be adding a pi every time until, when do I stop doing this? 2 pi. All right, the other way to take a look at this is take whatever's in here, set that equal to the normal period, and that's what you should be adding every time. So it may not always be pi in every case.
So tangent one.
Right, yeah, that's going to be different too. But what if I had a 3 theta in here? That's going to change some things up a little bit too, because then I would be adding a pi over 3 to everything. Or I'm sorry, a 2 pi over 3 to everything. Okay, so it changes the frequency as well. So I have to be adding a pi to each one of these, so that's 12 pi over 12 plus a pi over 12.
13 pi over 12.
13 pi over 12, that's another solution.
Can't have another one.
This is a 12 pi over 12. That's going to get me where?
17.
17 pi over 12. Is that still okay?
Yeah.
All right, when do I stop?
24 pi over 12.
Right, because that'll get me past the 2 pi. So if I add another 12 pi over 12 here, I'm going to get 25 pi over 12.
Nope.
Too many. So how many solutions am I going to end up with here?
Watch, bro.
4. So I have pi over 12, 5 pi over 12, 13 pi over 12,
Oh my goodness.
and 17 pi over 12.
That's still not hard. Sounds okay.
Is that hard enough for you?
No.
No? No?
It's
Don't tell me
very
it's
hard
gonna get
enough.
harder.
Okay.
I think
Don't
it's hard
worry.
enough.
Okay, good.
Let's just
I can't
stick
get
with
this.
The numbers, I don't understand.
What does this mean?
Let's try another one.
We have to do together.
Yes.
Oh, man. Yes.
White, white.
Can we just go?
I'm gonna start to skip that.
All right, so let's try to do the same thing that we did before. Let's let that be x.
Yeah.
So tangent of x equals 1. All
Seriously?
right, when's that going to happen?
Never.
Oh, when
It's a 90
it's
degree
something
angle.
else.
Or when it's just straight up.
If it's a 45-degree angle, it's
Straight up.
45-degree angle, why?
1 minus square root of 2.
Square root 2 over 2.
So,
Why will that work? Because tangent is opposite over adjacent, and that means that the opposite and adjacent have to be the same. The only place that that's going to happen is a 45, 45, 90. Now it's positive, so tangent is positive in the first quadrant. They all are.
Third.
And the third. Because they're both negative, so I'll get -1 over -1, still a positive 1. All right, so what angles are those?
45.
Trippy.
45. So I get in radians,
Pi over 4.
and the other one?
5 pi over 4.
yeah, that one.
Alright.
Yeah.
Of course it's right.
Okay, but that was when I was solving for x. It's not x.
No.
It's theta minus pi over 2.
So we have to add pi over 2.
Okay, so I have to add pi over 2 to both sides.
So it's like 5 or which one pi over 2? So that's 3 pi over 4. Right?
No, it'd be 2 pi.
This is,
over 3.
yes, 3 pi when you're all done. I thought you were changing this one. Yeah,
I
so-
changed it to 2 pi over 4.
Okay, so then when you add them, so this is really a 2 pi over 4. Then when I add that to another one, that's where we get our 3 pi over 4, so you're right. And then this is a 2 pi over 4 again, 7 pi.
But wait,
Over
there's
4.
more.
Well, for this one, did I have a frequency change for this one?
No.
No, so I don't have to worry about being squeezed or anything. It's your normal tangent graph, it's just everything got shifted over a little bit. And this, by adding the pi over 2 to both sides, that took care of the shift. So those are the only two that I'm going to get.
Can you do me a favor?
Yes.
Can you put a 2 in front of that theta and teach us how to do it with that?
Sure.
Changing this?
So if we had the tangent of 2 theta minus pi over 2 equals 1.
We have the same two
Will
answers.
these be on any quiz when you put one on the system?
It's easy.
So you have,
This will be a little bit different.
you have the same answers, right? It's just what would you do?
No, I think this one's going to be a little bit different because not only am I changing the frequency.
Oh yeah, because you have to put the 2 pi minus in front of it. And then
Right. So I am going to do the same method. So I'm
Well,
going
we'll
to change
still
this
get
back to be tangent of x equals 1.
We'll still get the pi over 4 and then pi.
Right. So that I'm still getting these same pictures.
So
So I'm getting a pi over 4
pi.
and a 5 pi over 4.
Right.
Right, but these are going to equal a 2 theta minus pi over 2 and a 2 theta minus pi over 2.
Now we add again, but then we have to divide it too.
Okay, so when I add this
So you get
plus a
3.
pi over 2, I still get my 3 pi over 4. Same thing over here. I'm going to get a 7 pi over 4, but
Multiply by 1/2.
now this equals 2 theta. So I'm going to have to multiply by 1/2 for both sides. So I'm going to get 3 pi over 8 and a 7 pi over 8. All right, so those are going to be two of my solutions. And then I need to figure out what the other ones are going to be. So we start with the frequency change, which is 2 theta. What's it supposed to be for tangent? Pi. Divide both sides by 2. So I need to be adding a pi over 2 to each one of my solutions down here. Until when can I stop?
No, I.
I think it's a pi.
Well,
So that's
what did my original problem say? I want everything in between 0 and 2 pi. So when do I get to quit? At 2 pi. So for us, since we're in terms of eighths, 16 pi over 8 is when I can quit. All right, so how many eighths is this going to be? This is really 4 pi over 8. So I'm going to get 7 pi over 8. Am I okay there?
Yeah.
Yep. And then if I add this one, this is really 4 pi over 8. That's 11 pi over 8. Am I still okay there? Yep. What if I add another 4 pi over 8?
You already have 11.
I already have that one, so I'm good there. And if I add another 4 pi over 8 here, am I still okay?
Yeah.
Yep, because I'm going to get 15 pi over 8. And then after that, clearly I'm going to have too many. Okay, so I got 5 solutions for that one.
No, you didn't. The 7 pi over 8 equals 7 pi over 8.
Oh yeah, this one I already had anyways. Good catch.
So,
So I really only had 4 solutions, 4 unique solutions.
that's not fun.
Kind of see how these work?
That's not bad though.
I think by doing that substitution thing, it makes it a lot simpler because then you're not trying to overthink it. It's just, all right, it's a tangent. Tangent's positive where? And then you figure out what these need to be and then go back. But it wasn't an X, it was this. Resolve. Right? The tricky part is going to be when you don't have just a theta by itself, trying to figure out what you need to be adding by until you can stop.
Don't ask.
Just like what we did here, right? Where we had to change when we had a frequency change. Okay? Got it? Okay. There's your homework.
You have homework?
Oh my gosh. Wrong two people.